In this video, we're going to learn how to build something called Pascal's Triangle. Pascal's Triangle is a tool that was developed by a French mathematician named Blaise Pascal. And it's a triangle of numbers that's going to give us a shortcut to solving problems like this one. This is called a binomial expansion. And so to solve this problem without using Pascal's Triangle, we would need to take the term x plus 3, write it 6 times in a row, and then apply the distributive property over and over and over again until we've multiplied it 6 times. And I know that's something that you're capable of doing, but let's see if we can figure out a shortcut for doing it. And Pascal's Triangle is going to be the way. Now, to build Pascal's Triangle, you're going to need a piece of paper, so let's make sure you have a blank piece of paper out and hold it the landscape way so that you've got plenty of room to write. On that piece of paper, what I want you to begin with is the number 1 at the very top. Now, right beneath that, you're going to put a 1 to the left of the 1 on top and a 1 to the right of the 1 on top. So you see that we're building a triangle with the 3 1s, a triangular shape with the 3 1s. Now we're going to start building successive rows to this triangle to build Pascal's Triangle. And to do that, we follow a very simple formula. The next row is going to begin with 1. In fact, every row in Pascal's Triangle begins with a 1. Now, to get the next term in this row, we're going to add the 2 terms above it. So to get this term, we're going to add 1 plus 1. And then we're going to close the row with another 1. So far, we have these rows in Pascal's Triangle, 3 rows in Pascal's Triangle. Now we're going to start the next row. We're going to start with a number 1 out here to the left. And now to get the next term, we're going to add the 2 terms above it. So 1 plus 2 is equal to 3. To get this next term, we're going to add the 2 terms above it. 1 plus 2 is equal to 3. And then we're going to close off the row with a 1. And so you see the nice triangular shape that's starting to develop. Let's go one more row. Put a 1 out here. Always begin with a 1. To find this next term, we're going to add 1 and 3. And that's the number 4. 3 and 3 is 6. 3 and 1 is 4. And then we're going to close the row with a 4. So far we've got 1, 2, 3, 4, 5 rows. Let's go ahead and add a 6th row. I'm going to start out with the number 1. We're going to add these 2 numbers to get this term, so we get a 5. Add these 2 to get this term, and we get a 10. We add these 2 numbers for a 10, 5, and 1. Now, I want you to stop here for just a second, and now we're going to number these rows. Now, it's not tricky, but it's just something that you've got to remember. When we number these rows, I've been counting them 1, 2, 3, 4, 5, 6, and that's actually a little bit incorrect. When we number the rows in a Pascal's Triangle, and this is going to be important because when we use it, we have to have the rows numbered properly. The first row, or the top row, is a 0. So way out to the left on your paper, I want you to put a 0 here, even with this first one. And so that's row 0. The next row is row 1. The next row is row 2. The next row will be row 3. The next row will be row 4. And the next row will be row 5. Now I want you to pause the video, and on your own, I want you to go ahead and write the 6th row of Pascal's Triangle. Okay, now that you're done, your 6th row of Pascal's Triangle should look like this one. 1, 6, 15, 20, 15, 6, and 1. okay? Now, I'm going to end the video now. I want you to stop the video, and on your piece of paper, I want you to continue building Pascal's triangle out to row number 10. So you're going to build 4 more rows using this method that we've just used. If you need to go back and repeat the video to help you build the subsequent rows, please do that, but don't move to the next item on the worksheet until you have a Pascal's triangle with 10 rows in it. And remember, use Pascal's triangle and have no fear of any kind of problem.